friends, I am Dr. Patil and this is the second session of electric charges and electric field. In the first session we have discussed about electric charge, its SI units and number of electrons required to have 1 coulomb, 1 millicoulomb, microcoulomb and nanocoulomb. And today we shall discuss basic properties of electric charges. And it is important for examination. That is, mention the basic properties of electric charges. They are additivity of charge, conservation of charge, quantization of charge. Then, what is additivity of charge? Consider a system consisting of 4 charges Q1, Q2, Q3 and Q4. Then the total charge on this system or total charge on this body is equal to Q1 plus Q2 plus Q3 plus Q4. That means that according to additivity of charge, the total charge on a body is equal to the algebraic sum of charges located at different portions of the body. This Q1, Q2, Q3, Q4, they are distributed at different parts of the body. Therefore, total charge on this body is equal to the algebraic sum of charges located at different portions of the body. Hence, Q equal to Q1 plus Q2 plus Q3 plus Q4 plus so on up to n charges. And if Q1 equal to 3 microcoulomb, Q2 equal to minus 5 microcoulomb, Q3 equal to plus 6 microcoulomb and Q4 equal to minus 8 microcoulomb, then total charge on this body is equal to 3 minus 5 plus 6 minus 8 microcoulomb, and it is equal to 3 plus 6, 9 and minus 5 minus 8, 13, minus 13 plus 9 is equal to minus 4 microcoulomb. Therefore, the total charge on this body is equal to the algebraic sum of charges located at different portions of the body. This is additivity of charge. And now consider a system consisting of 3 bodies, and let Q1, Q2 and Q3 be the 3 bodies, 3 charges on these bodies. This system as a whole is an isolated system. That means it is free from external forces. And here these 3 bodies are free. There is a force of attraction or repulsion between them. Then if Q1 equal to 2 microcoulomb, Q2 equal to minus 7 microcoulomb and Q3 equal to plus 3 microcoulomb, then according to additivity of charge, the total charge on this system of bodies is Q equal to 2 minus 7 plus 3 microcoulomb, and 2 plus 3, that is 5, plus 5 minus 7 is equal to minus 2 microcoulomb. Therefore, the total charge of an isolated system is minus 2 microcoulomb. And if this system is shaked, then the body, second body rubs with third body, and we know that due to rubbing, charges are transferred from one body to another body. Let second body transfers charge to third body, then the new charge on the system will be total charge Q equal to, that is Q1 equal to 2 microcoulomb, but Q2 transfers 2 electrons to Q3. Therefore, here minus 7 microcoulomb charge, out of minus 7, minus 2 microcoulomb charge is transferred to Q3. Therefore, charge on Q2 is minus 5 microcoulomb. And Q3 receives minus 2 microcoulomb charge. Therefore, the charge on the third body, that is Q3 equal to plus 3 microcoulomb, it receives minus 2 microcoulomb charge. Therefore, plus 3 minus 2 microcoulomb is equal to plus 1 microcoulomb. Now, the total charge on this system will be 2 plus 1, 3, plus 3 minus 5 is equal to minus 2 microcoulomb. That means, in this case, the total charge of an isolated system remains constant. Initially, they have plus 2 microcoulomb, minus 7 microcoulomb, plus 3 microcoulomb. Therefore, total charge on the system is minus 2 microcoulomb. And when one body transfers charge to other body, then also the body which transfers charge becomes positively charged, that is less charge, negative charge, and the body which gains charges, that is electrons, becomes negatively charged, minus 2 negatively charged, but initially it is plus 3 microcoulomb and it receives minus 2 microcoulomb, hence it becomes plus 1. In this process, the total charge before and after transmitting the charge remains the same. Initially it is also minus 2 microcoulomb, and when a body transfers charge, then also the total charge of the system remains constant. Therefore, according to the conservation of charge, the conservation of charge can be stated in two ways. Number one, the total charge of an isolated system remains constant, and charge can neither be created nor be destroyed. Here charge is not created or destroyed, but it can only transfer from one body to another body. This is the conservation of charge. And now, quantization of charge. Charge is quantized. Charge is quantized means it transfers a definite amount of charge. Definite amount of charge. In the market, you can buy a single book or 2 books, 3 books, or any number of books. But you can't buy a part of a book. That means 1/4 part of book, half or 3/4 part, you can't buy. You should buy in a definite amount, that is 1, 2, 3, so on. Similarly, bodies also transfer charge in definite amounts. Therefore, according to quantization of charge, the total charge of a body is equal to an integral multiple of fundamental charge, where n equal to 0, 1, 2, 3, so, and E is the fundamental charge and its value is 1.6 into 10 to the power minus 19 coulomb. Therefore, according to quantization of charge, the total charge of a body is equal to an integral multiple of fundamental charge, that is Q equal to plus or minus Ne. If a glass rod rubbed with silk cloth. Glass rod transfers charges or electrons to the silk. Therefore, glass rod becomes positively charged and silk becomes negatively charged. And suppose if glass rod transfers electrons, that is 10 raised to 3. Suppose 1000 electrons are transferred to silk. Therefore, total charge on the glass rod is Q equal to plus Ne, because it transfers charges, hence it becomes positively charged, 10 raised to plus 3. And it can be calculated Q equal to 10 raised to 3 into electronic charge is 1.6 into 10 to the power minus 19, and that is equal to 1.6 into 10 to the power plus 3 minus 19 minus 16. Therefore, when a glass rod transfers 10 raised to 3 electrons, then number of electrons transferred n equal to 10 raised to 3, that is 1000 electrons, into fundamental charge, that is equal to 1.6 into 10 raised to minus 16 coulomb. Similarly, the charge acquired by silk cloth is given by Q equal to minus Ne. Q equal to minus Ne, where N is the number of electrons received and minus sign indicates that it became negatively charged body. Clear? And these are very important, that is mention the basic properties of electric charges, that is additivity of charge, conservation of charge and quantization of charge, for 3 marks. Only name them. Then general properties of electric charges. Consider a body, and charges always reside on the surface of bodies. On the surface of bodies. Therefore, charges reside on the surface of the body. Secondly, density of charges is directly proportional to curvature. Consider irregular body on which charges are abundantly reside at the curvature or pointed ends. At the pointed ends, charges are resided abundantly. That is, number of charges at end points is more than the charges on regular shapes. Here charges are uniformly distributed, but at the end points they are more abundant. That means density of electrons, number of electrons is directly proportional to curvature. That means if more the curvature, more charges are resided. Clear? And reside. This is irregular shaped body, and on irregular shaped body, charges resided at the end points. More charges are resided at end points, and therefore due to identical charges, same charges, there is force of repulsion between these charges. Therefore, these charges can easily move to the surroundings, and this effect is called corona discharge. What is corona discharge? More charges are resided at end points, and due to repulsive force between them, they easily discharge, they easily move to the surroundings, and this process is called corona discharge. And lastly, regular uniform on regular shaped bodies. Regular shape, that is a spherical surface, is considered as a regular surface or uniform surface, and on uniform surface body charges are uniformly distributed. Charges are uniformly distributed, and they are non-uniform on irregular bodies. Lastly, like charges repel and unlike charges attract each other. And in last class you have studied two protons and two electrons repel each other. That is, like charges repel each other, but a proton attracts electron. That is, unlike charges attract each other. Clear? Now, based on this class, important question for 3 marks. Mention the basic properties of electric charges. The basic properties of electric charges are additivity of charge, conservation of charge, and quantization of charge. Clear? Then, for 1 marks, what is corona discharge? What is corona discharge? Charges at end points are abundantly accumulated, and due to repulsive force between them, they easily discharge to the surroundings, and this process is called corona discharge. It is for 1 mark. Clear? And I request you to please like, subscribe and press bell icon so that you will get notifications of next video classes. Thank you.